Okay, the problem on the homework is an education researcher is interested in studying performances of SAT scores. They're going to do a sample of 200 students, so we know that n is equal to 200, and that the new sample mean is equal to, Xbar is equal to 1600, with a standard deviation of 90. Okay, the first thing we want to do is figure out what our standard error of the mean is, and we already have a formula for that, and we know that the standard error of the mean is just equal to the standard deviation we were given before, divided by the square root of n. So if I plug in, hold on, bear with me, I'll let the camera adjust. If I plug in my numbers, I'm left with 90 over the square root of 200, which is equal to 6.36. 6.36 is my standard error of the mean. You will then take this to construct your confidence interval. I'm being asked to construct a 95% confidence interval. So to do a 95% confidence interval, I'm going to take my X bar plus or minus, and this was given to us, 1.96 times my standard error of the mean. So if I plug everything back in again, I'm going to be left with 1600 plus or minus 1.96 times my 6.36. Okay, this term here is equal to 12.47336. So then I'm left with 1600 plus or minus 12.4766, which then means that my confidence interval, there are two numbers here. If I were to draw this out, my mean here is 1600, and my 95% confidence interval means that I'm 95% confident that all scores, and if I were to go out to the population, would be somewhere in between 1587.53 and 1612.47. Please note also that when you're doing the rounding, you want to leave your answer. Hold on a second. You want to make sure that you leave or give your final answer at least 2 decimal spaces outside, greater than the data we were given. And given that we were given 200, 1600, and 90, we want to make sure that we leave 2 decimal places out.